Hey there, and welcome. Today, we're putting on our detective hats because we're about to uncover a hidden secret that runs the world of metals. It's kind of like a secret power that explains exactly why they act the way they do.
I mean, really think about it for a second. You've got some metals, like sodium, that are so wild they literally explode the second they touch water. And then you have others, like the gold in a sunken pirate ship, that can just chill at the bottom of the ocean for thousands of years, completely unfazed. So what's the deal? Why are they so different? Well, that's the big mystery we're going to solve today.
All right, let's get right to the evidence. Our investigation is going to start with the most basic test you can think of. We're going to see how our metallic suspects handle themselves when they meet the air and we turn up the heat. You could call it their trial by fire.
So our very first clue comes from a pretty simple experiment, one you might actually recognize from your Class 10 labs. We just take a bunch of different metals and we introduce them to a flame. The goal here is simple. Just watch. What happens? Do they catch on fire? Do they just change color? Or do they do absolutely nothing at all?
And what we find is, well, a whole range of reactions. On one end, you've got potassium and sodium, which are so ready to go, they just burst into flame instantly. Then you have magnesium, which puts on this incredible show with a super bright, dazzling white light. Others, like aluminum and zinc, they don't burn, but they get this kind of dull coating on them, and copper turns black. But then, way at the other end, you've got silver and gold. They're like the cool kids in the back of the class. They don't react at all. You can already see a pattern starting to form here, right?
So what's actually going on here at a chemical level? Well, what we're watching is a really fundamental reaction. The atoms of the metal are literally grabbing onto oxygen atoms from the air and combining to make something totally new called a metal oxide. The speed and the intensity of this reaction, that's our first huge clue to each metal's hidden power.
Okay, so the trial by fire gave us some pretty good hints, but now it's time to really up the stakes. We're going to put our metals through their next big challenge, the water gauntlet.
And you can tell right away that water is a much tougher test. In fact, some of our metals are so unimpressed by regular cold water that we have to bring out the big guns. We have to use steam. This tells us we're definitely dealing with different levels of, well, eagerness to react. And check out these results. They make that hidden hierarchy even clearer. Potassium and sodium, they're still at the top of the chart, going totally nuts even in cold water. Calcium is a little bit calmer. Magnesium, it won't even bother reacting unless the water is hot. And then you have aluminum, zinc, and iron. They won't do a single thing unless you blast them with steam. And, no surprise, down at the bottom are lead, copper, silver, and gold, showing zero reaction.
You know, the big chemical clue here is the release of hydrogen gas. When a really reactive metal gets into water, it basically rips the oxygen atom away from the water molecule and just kicks the hydrogen out. So those bubbles of hydrogen you see, that's the dead giveaway that a reaction is happening.
We've tested them with air, we've tested them with water. Now it's time for the final, most definitive piece of evidence in our whole investigation. This is the acid test, and it's going to give us our clearest ranking yet.
And wow, this really shows the difference in personality. When we drop these metals into some dilute acid, we're just looking for one thing: how fast do bubbles form? And magnesium, it just fizzes like crazy. It's the most vigorous reaction by far. Aluminum and zinc are next, but they're noticeably slower. Iron is even more sluggish. And copper, it just sits there, nothing. No bubbles, no fizz, zero reaction.
And once again, what are those bubbles? Yup, it's our old friend, hydrogen gas. See, the more reactive a metal is, the more desperately it wants to react with that acid to form something called a salt, and the faster it kicks out that hydrogen gas. It's a direct measurement of its chemical urgency.
Okay, let's just take a breath and look at all our evidence. We've seen some metals that react like crazy with air, with water, and with acid, and we've seen others that pretty much do nothing at all. All these clues from all three of our tests, they're all pointing to one single unifying answer. So, what is it? What's the secret pattern that connects all of this?
This is it. This is the master key, the secret decoder ring that explains everything we've just witnessed. This is the reactivity series of metals.
So the reactivity series is basically a power ranking for metals. It's that simple. Up at the top, you've got the most reactive ones like potassium and sodium. Those are the guys that burst into flame. And as you go down the list, their reactivity, their desire to get into a chemical reaction just drops and drops, all the way down to the super unreactive metals like gold at the very bottom. This one list explains every single result from all of our experiments.
So now we have our master list. But does it actually work?
Can we use it to, predict the future? Let's put our newfound knowledge to the test in one final showdown.
So check this out. We take a regular iron nail and we place it in this blue solution of something called copper sulfate. Now, looking at our reactivity series, can you predict what's about to happen? Which metal is the more powerful one in this matchup?
Well, if you look at the series, you'll see that iron is higher up on the list. It's more reactive than copper. And the rule here is super simple. The more reactive metal always wins. The iron will literally kick the copper out of the solution and take its place. This is called a displacement reaction. The stronger metal pushes out the weaker one. It's that simple.
And this isn't just some abstract chemistry thing for the lab. This explains the world all around us. Why are cars made of steel? Well, iron, which is what steel is mostly made of, is reactive enough to be strong and useful, but it also rusts. That's just it reacting with oxygen. But gold, way down at the bottom of the series, is so unreactive it will pretty much never corrode. And that's exactly why it's perfect for tiny, sensitive electrical contacts inside your phone that absolutely cannot afford to fail. This secret power of metals is literally everywhere.
So you see, the reactivity series isn't just some list in a textbook, it's the code for understanding the material world. So keep looking around you and keep asking why things behave the way they do. And hey, if you're a Class 10 student and you want more awesome science deep dives just like this one, you should for sure check out the A1 Institute over on YouTube. They've got some fantastic explainers. Thanks for digging into this with me.